we talk about adrenergic nervous system, we are actually referring to ayan, sympathetic nervous system. They're just equivalent. Okay? Basta adrenergic nervous system, we are referring to sympathetic nervous system. And based on these information, we can think then of some of the neurotransmitters involved here. Particularly, I am talking about those neurotransmitters na found in the postganglionic neuron ng sympathetic nervous system. When we say postganglion na mga neurotransmitters or postganglion neuron, yun yung pangalawang neuron ha, or the second sending neuron in the two neuron setup of ANS. Okay, again, postganglion neuron, yun yung pangalawang neuron. Okay, pangalawang sending neurons. So I am talking about those neurotransmitters found on the postganglion neuron. And those neurotransmitters involved are what we call the natural catecholamines. Okay, catecholamines. Again, natural catecholamines. Now, under natural catecholamines, diba, there are 3 neurotransmitters under here. So, para dili malimtan, you can use the mnemonics NED. Okay, NED. This pertains to norepinephrine, epinephrine, and then dopamine. Okay, if you could still remember, last meeting man siya. Norepinephrine, epinephrine, dopamine. Okay, now as we go along our discussion, we actually have a separate segment to specifically discuss these natural catecholamines, specifically in terms of their pharmacology. Okay, so madiscuss natin na ilahang mechanism of action sa body. And take note, regarding natural catecholamines, we have the principal neurotransmitter here, and that is the norepinephrine. Okay, norepinephrine as the principal neurotransmitter. Okay, so let us start discussing the specific steps involved in adrenergic neurotransmission. Okay. Now, the same pattern lang gihapon, the same pattern how I discussed the cholinergic transmission, I will discuss it separately. Yung processes specifically, I will discuss separately the processes. Ayan, so hahatiin ko siya into 3 parts ulit, involving the pre-synapse sa taas. We have here the pre-synapse, okay, and then we have in the middle the cleft, the synaptic cleft, and here would be the post-synapse. Okay. So start tayo everyone sa pre-synapse ulit. Okay, pre-synapse ulit. So for the nth time, under pre-synapse, so pasok dito yung synthesis, storage, and also release of neurotransmitters. So let us start with una, synthesis. Okay, particularly since we're talking about adrenergic neurotransmission, this would be synthesis of the following natural catecholamines, yung NED. Okay, the norepinephrine, epinephrine, and dopamine. Okay, so let me magnify first the figure. Okay, on top. For the synthesis, let us start with the compound, with this compound specifically, which is isang amino acid. Okay, so we'll start with this compound in the name of tyrosine. I believe you're all familiar with this amino acid, tyrosine. This is considered the precursor amino acid, no, in the biosynthesis of NED, the biosynthesis of natural catecholamines. When I say precursor, Sulat ko ha. When you hear about um, the term precursor, that refers to the raw material. Okay, raw material that is needed para to produce natural catecholamine. So, what will be the fate of this tyrosine inside the pre-synapse? What could be the fate? What will be the fate of tyrosine inside the pre-synapse? So, in the pre-synapse, tingnan yung tyrosine, it is being catalyzed by an enzyme, no? It is being catalyzed by an enzyme called tyrosine hydroxylase. Okay? Now, once catalyzed, this reaction causes formation of an intermediate product known as DOPA, or this is the L-DOPA. Okay? Again, you have tyrosine. It is being catalyzed by an enzyme, tyrosine hydroxylase, and that reaction will tend to form the intermediate product, which is DOPA, or also known as L-DOPA. You can just search, no, sa Google ano yung buong pangalan ng L-DOPA. This is just an abbreviation, no? So, if you're curious about that, you can, one tab away lang naman siya. Yung point ko lang here is isa siyang intermediate product, okay? Ang L-DOPA. Mula sa rate limiting step, okay? Tyrosine reacting with tyrosine hydroxylase, you'll form an intermediate product, L-DOPA. Now, once L-DOPA is formed, okay, take note, once L-DOPA is formed, it will be further catalyzed by another enzyme. I repeat, L-DOPA, itong L-DOPA will serve as a substrate. Okay, substrate for the enzyme called L-DOPA decarboxylase. Okay, again, L-DOPA will be targeted by the enzyme called L-DOPA decarboxylase, okay, resulting to the formation of another compound, which is dopamine. Okay, again, that will lead to formation of dopamine. Now, question, ang dopamine ba ay member ng NED? Apparently, yes. Diba? Dopamine is a natural catecholamine. Therefore, based on this knowledge, we can infer then that dopamine is the first natural catecholamine being produced in the body. Okay, so take note, dopamine, siya yung unang na-synthesized based on this pathway. Sige, let us continue. That is for the synthesis of dopamine. Okay, let us continue for the storage naman. Storage. Okay. So, sulat ko, storage. Now, kapag na-form na yung dopamine, kanang na-encircle o kulay blue, kapag na-form na, na-produce na yung dopamine, tandaan, ang dopamine will undergo specialized process. Again, it will undergo a specific process. And that specialized process is called vesicular storage. Okay. Again, dopamine will undergo vesicular storage process. Now, when we talk about vesicular storage, apparently, as the term suggests, dopamine will enter. Okay, it will enter into the vesicles. Papasok ang dopamine sa loob ng vesicles. And yung entry ng vesicle, okay, ng dopamine into the vesicle is made possible by a transporter. And that transporter is called VMAT. Okay? VMAT yan. Okay, VMAT. Okay, VMAT stands for, dili na lang na ako isulat ha sa kilid. VMAT stands for vesicular monoamine transporter. Again, entry of dopamine into the vesicle is made possible by VMAT. Okay? By vesicular monoamine transporter. Now, question, ano yung essence ng entry of dopamine sa vesicles? Ano ba yung essence ng entry of dopamine sa vesicles? So some of you, I know, you already have an idea. So take note, similar with what I have mentioned last meeting, the importance of dopamine's entry into the vesicle is for the prevention, no? Prevention of its premature metabolism. Again, para maiwasan yung premature metabolism. Okay? Now, bakit ulit may tendency na ma-metabolize ang dopamine sa loob ng pre-synapse? Recall that this is due to the presence of enzymes inside the pre-synapse. Okay, so dopamine again, take note, mula sa iyahang synthesis, it has to be stored. Okay, dapat itago yung dopamine. Next, let us continue. Suppose may dopamine na. So imagine niyo may dopamine na nakapasok sa vesicle. Okay? Pero as you observe, 'di ba, shortcut yung presentation. Okay? Shortcut yung presentation sa figure. By the way, itong mga figures na to sa transmission, cholinergic, adrenergic transmission, I lifted this figure from the Katzung, yung reference book natin sa pharmacology. Okay? So kung titingnan niyo sa loob ng vesicle, shortcut siya, no? As dopamine enters the vesicle, norepinephrine na agad. Diba? Nakikita nyo sa loob. May nakikita kayo sa loob na NE, yan yung norepinephrine. So, norepinephrine na agad yung na-produce. So, to provide clarity sa portion na to, para mas maintindihan ba? Okay? Kung bakit norepinephrine. Okay, naging norepinephrine yung dopamine sa loob ng vesicle. So, let me discuss here on this side yung mas klaro na process sa loob ng vesicle. Okay? So, imagine this is the vesicle. Okay? That is the vesicle. And then we have the dopamine. Okay? A dopamine that just entered in the vesicle. It just entered in the vesicle. Now, kapag may dopamine na sa loob ng vesicle, take note, ang dopamine will be targeted by an enzyme. It will be targeted by an enzyme. Okay? So, may enzyme sa loob ng vesicle. In this case, the enzyme is specific to catalyze dopamine. And that enzyme is known as dopamine. Okay, take note, that is dopamine beta hydroxylase. Okay, again, that enzyme is dopamine beta hydroxylase. Now, once targeted, this would eventually lead to synthesis. It will lead to synthesis of norepinephrine inside the vesicle. Okay? Kaya dito, makikita niyo sa figure, di ba, may norepinephrine na nabuo sa loob ng vesicle. Okay? So that is again formed by enzymatical reaction of dopamine with dopamine beta hydroxylase inside the vesicle. Okay, so again, based on this information, we can realize then that it is the norepinephrine. Take note, it is the norepinephrine na natural catecholamine that accumulates, okay, that accumulates inside the vesicle. Okay? So among the um, natural catecholamines, ang mas nag-a-accumulate nga neurotransmitter inside the vesicle are norepinephrines. Okay? That is why ang norepinephrine is now ready for exocytosis. Okay? Ready na siya for exocytosis or release. Okay? So kapag with that knowledge, okay, norepinephrine yung concentrated sa vesicle, norepinephrine yung ready for exocytosis, this is actually the reason bakit yung norepinephrine is deemed to be the principal neurotransmitter. Okay? Kasi nga, ito yung form of catecholamine na marami ang nailalabas from the vesicles. Kaya, principal neurotransmitter siya in this case. Okay? So, overall, we are done with synthesis, including storage of both dopamine and also norepinephrine. Okay? By the way, for epi, yung kay epinephrine, utang ko muna ha, mamaya after this figure, meron tayong special case sa kanya. Okay, later on you will understand why special ang kay epinephrine. Okay, so let's proceed muna to the release of norepinephrine. Okay, release ng norepinephrine. Okay, with regards to the release, okay, the same process lang naman, no? The same process of release will happen to norepinephrine with that of acetylcholine na na-discuss ko last meeting. Okay, diba recall, under release, yung calcium ion is very important, wherein it will enter through this voltage-gated ion channel, causing movement of these vesicles attaching to the docking proteins. Okay, so we have VAMPs, the SNAPs. Okay, so I believe you have searched already the meaning of these abbreviations, VAMPs, SNAPs. So these are docking proteins. So with this attachment of vesicles to the docking proteins, release, okay, of norepinephrine will now happen. Okay, and that is via exocytosis. So the same process lang yung kay acetylcholine. Yun yung process din ng release ng norepinephrine. Okay? So at the end of this process above, okay, at the end of this process above sa presynapse, we tend to observe here that norepinephrine being the principal neurotransmitter is now made available in the synaptic cleft. So available na siya ngayon sa synaptic cleft. I repeat ha, later we will have a special discussion lang involving epinephrine production. So mamaya na yung kay epinephrine. Okay, so yung mga na-discuss ko pa ngayon is kay dopamine, including kay norepinephrine. Mamaya yung kay epinephrine. Okay. Now, since ang norepinephrine, so dirita, ayan. Since ang norepinephrine is now present in the cleft, okay, let us discuss what are the possible fates naman. Ano yung posibleng destiny ng norepinephrine into the cleft? Okay, again, i-discuss natin dito naman sa side yung posibleng fates, destiny ng norepinephrine into the cleft. In general, there are two possible fates, no? Two possible fates of norepinephrine. Number one, based on the general knowledge of neurotransmitters whenever available sa cleft, di ba sabi natin, since liberated na sila dito sa cleft, ready na sila for binding into the receptors. Okay? That is why unang possible fate no, ng norepinephrine in this case is involving, ayan, binding also, binding to post-synaptic receptors. Okay? Again, first possible fates ng norepinephrine involves binding of norepinephrine in the postsynaptic receptors. Okay, recall. Binding of neurotransmitter to the receptors is an evidence na nai-induce na yung transmission sa kabila. Kumbaga naipasa na yung balita. Now question, do you think this first fate of norepinephrine would lead to enhanced or reduced sympathetic effect? Does it lead to enhanced or reduced sympathetic effect? Okay, very good. Okay, enhanced effect. So, sulat nyo, enhanced effect. Yan yung net, yung kumbaga take-away learning nyo for the first fate. Okay. Second, for the second, dito kayo sulat. For the second fate of norepinephrine, yung general term is termination. Again, yung general term is termination, okay, of norepinephrine. Again, termination of norepinephrine. Kapag sinabi nating termination, di ba, terminate, it is being removed. Na terminate, remove, tinanggal, inalis, no? Termination of norepinephrine. Yan yung isa sa mga fate niya kapag andito sa cleft na siya. Overall, there is removal, no? Removal of norepinephrine in the cleft. And that causes, take note, reduction of sympathetic effect. Okay? Take note, yung sa second fate, possible fate ng norepinephrine sa cleft is termination of norepinephrine. So generally, that would ultimately cause to reduction of sympathetic effect. Kasi nga, tinatanggal na re-remove ang norepinephrine sa cleft. Okay? That leads to reduction of the effect. Okay? Now, with that being said, let me discuss the termination mechanisms of norepinephrine in the cleft. Okay? So, we actually have three. Okay? Three mechanisms involved here under termination. So, una, letter A, norepinephrine could undergo, take note, passive diffusion. Okay? Again, it can undergo passive diffusion into the systemic circulation. Again, norepinephrine, okay, under termination it could undergo passive diffusion into the systemic circulation. In other words, para siyang wina-wipe out ba? Okay, gina-wipe out siya. Gina-wipe out ang norepinephrine doon sa cleft. So, inaalis siya, wherein napupunta siya doon sa dugo. Kasi nga, systemic circulation. So, napupunta siya sa dugo. In this case, lesser level of norepinephrine in the cleft. Lower yung number of norepinephrine that will be liberated, okay, sa cleft, leading to reduced sympathetic effect. Okay? Sige, let's continue. That is why, kung titingnan nyo dito sa figure, merong nakasulat na diffusion. Arrow mula sa norepinephrine, then diffusion. Okay? So, yan yung unang mechanism ng termination of norepinephrine sa cleft. Next, letter B. So letter B, this mechanism is predictable. Okay, recall, in the cleft, there are enzymes. Okay, there are enzymes here sa cleft. So ano yung posibleng mangyari kapag may enzymes? Letter M, metabolism ulit. Okay, metabolism. Okay. So again, dahil sa presence ng enzymes in the cleft, posible yung metabolism. Okay? And the enzymes, take note, the enzymes responsible for the metabolism of norepinephrine and also epinephrine. Kasali din siya. Okay? Ang metabolism dito, pwedeng affected yung norepinephrine, kasali din si epinephrine. And these are the following enzymes. We have MAO, or the monoamine oxidase, and the COMT, or the catechol O-methyl transferase. So again, you can search one tab away ulit sa Google. You can search for the whole word ng MAO at saka COMT. Okay, yung point lang dito, these are the enzymes, again, the degradation enzymes wherein capable of degrading norepinephrine, including epinephrine, rendering them inactive. Okay? So, common sense, kapag inactive na yung norepinephrine, of course, it cannot bind to the postsynaptic receptors. That is why lesser ulit yung sympathetic effect. 'Di ba? Kung inactive na yun, syempre, that is not the correct, let's say, structure ng mismong neurotransmitter that is capable of binding to the receptor. Kasi nga, inactive form naman siya. Okay? So, under siya sa termination, gihapon, mechanism ng termination of norepinephrine, which leads to reduced sympathetic effect. Lastly, we have the reuptake, letter C. We have here reuptake process. Okay? Reuptake process. Now, mind you, class, that reuptake process is responsible in the majority of termination involving norepinephrine. Okay, so meaning to say, among these three termination mechanisms, itong letter C, yung mostly pronounced. Okay, kumbaga responsible siya in the majority of removing norepinephrine in the cleft. Now, ang reuptake process, that is being held by the transporter called norepinephrine transporter. Okay, again, this is the NET or norepinephrine transporter. Okay. Now, yung norepinephrine transporter, meron siyang AKA, or also known as. Meron siyang synonymous nga term ba. This is also known as uptake 1. Okay, uptake 1 transporter. Okay, AKA lang po yan ng norepinephrine transporter. I repeat, we have reuptake process responsible for majority of removing norepinephrine in the cleft. And this reuptake is facilitated by the norepinephrine transporter, also known as uptake 1 transporter. This time, let me explain first the term reuptake. Okay? Yung term na reuptake. Okay, so ano yung ibig sabihin ng term na reuptake? Okay, ato siyang i-break down into two. Okay, we have the re, and then uptake. Okay? Kapag sinabing re, di ba, prefixes, sa English na prefixes, kapag sinabing re is again, ulit, ulitin, di ba? Then kapag uptake naman, uptake, kukunin, kuhaon ba? Sa Bisaya, kuhaon siya, kukunin. Therefore, kung imo siya i-combine, re-uptake, kuhaon balik, no? Kukunin ulit. Okay? That's reuptake. That is why if we go back here, go back to sa figure on the right side. Ayan. As you can see, itong naka-highlight na kulay red. Okay? Ang norepinephrine, take note, it enters via, via net into the pre-synapse. Again, bumabalik ulit sa pre-synapse ang norepinephrine. And then, syempre, kapag nasa sa loob ng pre-synapse, it will be stored again. Okay, that will be stored again sa vesicles. So, yan yung reuptake. Bumabalik ulit, okay, papasok ulit sa pre-synapse, no, ang norepinephrine, and it will be stored. Question. Based on this information, taas or baba ang norepinephrine na nasa cleft? Taas or baba ang norepinephrine na nasa cleft? Very good. Okay, nice. Baba. Okay, so baba yung norepinephrine na nasa cleft. Overall, that would mean less sympathetic effect. Diba? Kasi nga, bumalik siya doon sa pre-synapse, wala na masyadong available sa cleft, lesser na yung sympathetic effect. Kasi lesser yung potential number of norepinephrine that could bind to the postsynaptic receptor. Kaya nga, di ba, itong process na reuptake, metabolism, passive diffusion, undertermination, in general, na fate of norepinephrine, which leads to decreased sympathetic effect. Okay? So I hope you are now enlightened na lahat sila would lead to reduced sympathetic effect. Letter A, B, and C. Okay? So these are the fates of norepinephrine. Destiny ng norepinephrine being the principal neurotransmitter in the cleft. And also pala, please take note, yung reuptake process, okay, specifically, ito yung characteristic ng norepinephrine that differs from acetylcholine. Diba? Wala pong reuptake. Hindi po, walang characteristic, walang ability si acetylcholine to have reuptake process. Sige lang, along our discussion, we will have an elaborate discussion on that. Basta, yung idea niyo lang for now, walang reuptake. Kung inyo siyang i-compare with the fates, walang reuptake process kay acetylcholine. Si norepinephrine lang yung capable. Okay? And then dito naman sa postsynapse, so ganun lang din, madali lang dito. Dito mangyayari yung binding of norepinephrine. Okay? Kasi andito sa postsynapse yung mga adrenergic receptors. Okay? So pag may binding, may effect, may sympathetic effect eventually. Okay? So that is for the processes involved in cholinergic, not cholinergic, adrenergic transmission. Okay? This time, let us proceed naman to the drugs. No? Drugs that affects these pathway. Okay? Under adrenergic neurotransmission. Let us begin now with the first drug. No? So let me magnify first. We have metyrosine, yung una. Okay, take note. Metyrosine, this is the one that blocks the enzyme. Ayan. So, kita naman, di ba, sa arrow. It blocks the enzyme tyrosine hydroxylase. So, it blocks the enzyme tyrosine hydroxylase. Again, metyrosine, it blocks the enzyme tyrosine hydroxylase. So, I think may idea na kayo kung ano yung posibleng mangyari dito. Diba? Block yung rate limiting enzyme, yung unang enzyme, para later on makabuo ng dopamine and other neurotransmitters. So question, do you think enhanced or reduced norepinephrine that will be produced later on sa process? Yes, very good. Reduced, no? Yung norepinephrine that will be produced, and overall, along the way, lesser sympathetic effects. Therefore, we can conclude then that metyrosine is an anti-sympathetic agent. Kasi nga, overall, it causes lesser sympathetic effects. Next, let us have reserpine. Okay, number 2. Ayan, we have reserpine. Okay. Ang reserpine naman, tandaan, this is an inhibitor of VMAT. Okay? So, yung arrow pointing to the VMAT minus, so inhibits. Okay? It is an inhibitor of VMAT. Okay? Now, question, saan related yung VMAT? Saang process related ang VMATs? Is it synthesis, storage, or release? Okay, very good. Okay, VMAT is very much involved to the storage of ng neurotransmitter in this case. Therefore, by targeting VMAT, okay, kapag tinarget yung VMAT, what do you think will happen to dopamine? Okay, what do you think will happen to dopamine? Listen, is it enhanced or reduced metabolism of dopamine? Okay, is it enhanced or reduced metabolism of dopamine? Very good, no? Enhanced ngayon yung metabolism ng dopamine. Okay. Now, kapag enhanced yung metabolism of dopamine, di ba? Maraming dopamine na nade-degrade, nag-undergo og premature metabolism. Therefore, we can infer then na mababa yung norepinephrine being synthesized. Okay? Kaya overall, kapag tinanong kayo, is reserpine pro or anti-sympathetic drug? Pro or anti, it is very good. Okay, it is an anti-sympathetic ulit na drug. Okay. Next, number 3. Involving the release of neurotransmitter, we have the following modifiers ng release. So, dito ko na lang siya isulat. Ayan. Number 3, we have those group of agents that alters the release. Okay, targets the release of norepinephrine. So, particularly, kapag sinabing alter, modify the release, they could either enhanced the release or reduced the release of norepinephrine. Okay, so under release, we have, let's start with stimulators. Okay, stimulators. Okay? Basically, when we say stimulators na-enhance, no? Na-enhance yung release of norepinephrine, na-enhance yung exocytosis ng norepinephrine. So with that, we can infer kung na-enhance yung release ng norepinephrine, these are said to be pro, no? These are pro-sympathetic drugs. Tama? Kasi nga stimulator na-enhance yung exocytosis ng norepinephrine. So may available na norepinephrine that could bind to the postsynaptic receptor. So more neurotransmission. Okay? Now, specific examples. Let's have the specific examples of stimulators. The following, we have tyramine. Sulat nyo na lang ha. Tyramine. We also have ephedrine. Okay, tyramine, ephedrine. We have amphetamine. These drugs will be discussed sa CNS drugs. Okay. Amphetamine, we also have the angiotensin 2. Angiotensin 2 yan, angiotensin 2. And the poison, also yung poison na alpha-latrotoxin. Alpha-latro. Kadali lang ha. Alpha-latrotoxin. Okay? Hindi gyapon siya klaro. Basta alpha-latrotoxin yan. So, these agents again can enhance exocytosis. Okay, enhancing therefore the sympathetic outflow. No? Next, punta tayo sa inhibitors. No? Inhibitors ng release of norepinephrine. So regarding inhibitors, ito yon. Ito yung mga inhibitors, okay, listed on the figure. Okay, so we have, ayan. So we have here bretylium, guanethidine, and kindly add, we also have guanadrel. Okay, guanadrel. Guanadrel. Again, ito naman yung mga inhibitors of exocytosis. Okay, specific inhibitors ng exocytosis. Okay, so apparently, these inhibitors would ultimately reduce the sympathetic effect because they prevent the transmission of impulses. Kasi nga, inhibit release of norepi. Diba kapag release ng norepi, dapat available na siya sa cleft. Inhibited nga. Okay? Inhibited yung release ng norepinephrine. Okay? Wala nang masyadong norepinephrine na nasa cleft. Okay? Lesser ang transmission ng impulses dahil lesser yung nagbabind sa postsynaptic receptor. Okay? Next, number 4, we also have drugs that targets reuptake process. Okay? So, ito yung number 4. Okay? Those drugs known as reuptake inhibitors. Okay? Again, reuptake inhibitors. Okay? Ito yung mga nakalista sa baba. Okay? When we say reuptake inhibitors in general, okay, these agents block the transporter that is needed for reuptake process. And ano yung transporter na yun for reuptake process? Diba? We have net. Okay? So, pigil yung transporter na net. Okay? Blocked with these agents. Okay? And as an implication, kung wala ng net, no, wala yung norepinephrine transporter, kung walang bridge, no, walang tulay, okay, for the norepinephrine to re-enter the presynapse, that will lead to lesser, okay, norepinephrine in the, I mean more, no? That will lead to more, okay, more norepinephrine in the cleft. Kasi nga, pinigilan, okay, blocked yung transporter, hindi na mariri-uptake, hindi papasok, pabalik sa presynapse yung norepinephrine. So, it will be concentrated lang dito sa cleft. It will be accumulated, it will be concentrated dito sa cleft upon inhibition of reuptake. So, no choice siya, kapag naas siya sa cleft, it will be readily binded to the receptors. And with that being said, with enhanced binding to the receptor, that can we can infer then nga enhanced, di ba? Enhanced yung sympathetic effect. Okay? So tell me, ang reuptake inhibitors ba ay pro or anti-sympathetic agents? Very good. Okay? So yan yung i-take note nyo. We have, that is a pro-sympathetic agent because again, they enhanced sympathetic effect. Okay, so specific examples lang, ayan, we have cocaine, we have the TCAs, okay, TCAs, or the tricyclic antidepressants, which will be discussed more under CNS drugs. Okay, pero just to give you an idea, no, this is an interesting idea also. I will share it now. As the term suggests, diba, TCA, kakadali lang, i-plaster sana ko. Diba, TCA, sabi, antidepressant. Kadali lang, eh. Lalag siya. Okay. So TCA, antidepressant, as the term suggests. So para saan? Okay, for depression. Di ba? For depression. Ano ba yung nangyayari sa depression? Kapag ang patient is diagnosed with depression, by the way ha, you cannot say easily nga, oh, I'm so depressed with all the stuffs, activity, etc. Dili ka pwede kay hadlok ka ayo ng sakit nga depression. Dapat ma-diagnose ka mental disorder man ng depression. Stress siguro that's acceptable. But do not use I am depressed. Okay? Kasi depression again has to be diagnosed, okay, by a psychiatrist, okay? Or also a collaboration with a psychologist. So ayan. Okay, so dapat ayun ninyo i-practice gud ang pag-use I'm so depressed. Okay? So it has to be diagnosed nga mental disorder. Ngayon, ano yung nangyayari sa patient diagnosed with depression? Yung nangyayari is yung mga mood regulators ng katawan, are being affected. Specifically, sobrang baba ng happy pill. Ano yung happy pill? Diba? Serotonin. And other mood regulators. We have the norepinephrine. Sobrang baba. Yan yung usually nga underlying cause kapag kung ma-diagnose ka og depression. Meaning to say, behind that underlying pathology is na ay mababa yung serotonin tsaka norepinephrine label mo. Now, based on the knowledge kanina, recall nga yung TCA, okay, as a reuptake inhibitor agent, ano yung ginagawa niya sa level ulit ng norepinephrine, di ba? As a reuptake inhibitor, ginagawa niya is tinataas niya yung level ng norepinephrine. And actually, with TCA, meron din siyang effect towards serotonin. Okay, tinataas din yan yung level ng serotonin. That is why reuptake inhibition of these mood regulators like norepinephrine, serotonin makes them a good antidepressant agents. Okay? Kasi nga ulit, ang underlying cause kapag may depression, mababa ang serotonin or mababa ang norepinephrine. Ano yung ginagawa kapag reuptake inhibition? Tinataas, no? Tinataas nila yung level ng mood regulators. Halimbawa, norepinephrine, serotonin. And yes, there are a lot, no? There are a lot of antidepressants wherein yung mechanism of action nila is ba to manage depression is via reuptake inhibition. Okay, ini-inhibit nila yung reuptake process ng mismong neurotransmitter. Okay? So kung inhibited yung reuptake, okay, concentrated sila ngayon in the cleft, increase yung level nila on the cleft available for action. Okay? Another example para inyo hang ma-appreciate yung antidepressants. Another example is yung selective, kamo na lang magsulat, selective serotonin reuptake inhibitor. Isa din po tong class ng antidepressant. Selective serotonin reuptake inhibitor. So obviously, ang ini-inhibit niya na reuptake process is selectively kay serotonin. Okay? So pwede din siya as antidepressant kasi nga yung ginagawa net result basta makadungog yun mo og reuptake inhibitors, life hack ana, tinataas nila kung ano man yung substance nga pinipigilan na i-reuptake. Okay? So tinataas therefore. Okay? Katulad nito. Kasi nga pigil yung pagpasok pabalik sa pre-synapse, 'di ba? So na-increase yung level ng mismong neurotransmitter. Na in this case, kapag selective serotonin reuptake inhibitor, pwede din siya as antidepressant kasi na-enhance niya yung anong neurotransmitter, serotonin. Tinataas niya yung serotonin which is a happy pill, 'di ba? Dili na siya kuan medical term ha, kanang kuan lang na siya layman's term, 'di ba, sa serotonin, happy pill daw po. Okay? So overall, these are the drugs, no, that targets the synthesis, the storage, the release of norepinephrine. So recall, we have the following drugs. Una, metyrosine. We also have reserpine. We also have the inhibitors and stimulators of release ng norepinephrine, and these two, cocaine and TCA for reuptake inhibitors ng norepinephrine. Okay, so done with this slide. Okay, now let us have this slide. Okay, specifically na-discuss naman to, so madali na lang yung slide na to. Okay, na-discuss na to sa previous slide, yung concept ba about synthesis ng catecholamine. So just to reinforce the biosynthesis ng natural catecholamines, di ba, we have here tyrosine, di ba, naalala? Tyrosine, then via tyrosine hydroxylase, it will form the intermediate product na L-DOPA. Okay? And then, yung L-DOPA will ultimately form dopamine. Paano? Via the enzyme ALAAD. By the way, ALAAD, equivalent lang gihapon na siya sa L-DOPA decarboxylase. ALAAD is, this stands for aromatic L-amino acid decarboxylase. So you can search on the internet. Okay, kung wala ninyo na catch up ang meaning for the abbreviation ALAAD. It's the same way that is also L-DOPA decarboxylase. Okay? And then after dopamine, sa loob ng vesicle, di ba, it will form norepinephrine. So ito lang yun. Then via the enzyme, and that is via the enzyme, dopamine, beta hydroxylase. So as you can see, di ba, may nakalagay na sympathetic nerve. Okay? So, mangyayari siya specifically sa loob ng vesicle. Ito, mangyayari sa loob ng vesicle. Next, explain ko this time yung utang ko kanina. Okay, yung utang ko kanina about epinephrine. Diba? Na ako'y utang kanina about epinephrine. So, let us suppose norepinephrine has been released. So, imagine niyo ha, norepinephrine has been released already into the synaptic cleft. Nasa synaptic cleft na yung norepi. Take note class na merong portion ng norepinephrine that reaches the adrenal medulla. Okay? Take note. Merong portion ng norepinephrine that reaches the adrenal medulla. Okay? And again, in the adrenal medulla, there is presence of enzyme. Okay? There is presence of enzyme there na susceptible sa norepinephrine. Okay? Again, merong portion ng norepinephrine mula sa cleft that will reach adrenal medulla. Asan yung adrenal medulla? Superior to the kidney. Now, in the adrenal medulla, merong enzyme susceptible doon ang norepinephrine. Okay? And that enzyme is PEN-MT or phenylethylamine and methyl transferase. So, yan lang yung ibig sabihin ng PEN-MT. Now, by that, nako-convert ang norepinephrine into epinephrine. Okay, so ito yung reason how epinephrine is synthesized in the adrenal medulla. Recall, I have mentioned this last meeting, naalala, that adrenal medulla stores majority of epinephrine. So somehow, you can connect now na yung concept na to, di ba? You can connect that concept and this one kung bakit nako-concentrate no, ang epinephrine sa adrenal medulla because again, the enzyme PEN-MT is present in the adrenal medulla. Yan yung kailangan, okay, to catalyze no, norepinephrine forming epinephrine. So overall, these are the biosynthesis of catecholamines. Okay? Last na lang. Pwede extend ko 3 minutes para 11:35. Okay? Last na lang. Next. Proceed tayo diri sa right nga figure. Okay? Right side ng figure. Itong pathway na to on the right, it has something to do with metabolism. Okay? So may label naman. Okay? Recalling the metabolic fate ng norepinephrine and epinephrine. Di ba? We have two enzymes. We have the MAO, okay, and the COMT. Okay, naalala? We have the MAO and the COMT to metabolize the catecholamines nga norepinephrine and epinephrine. So, focus nyo lang ngayon is on the ultimate. Diretso na mo sa ultimate product, no? Degradation product ng norepinephrine and epinephrine after metabolism. So, tandaan ang ultimate or overall product ng metabolism of adrenergic neurotransmitter na norepinephrine and epinephrine is 3-methoxy 4-hydroxy mandelic acid. Again, it's 3-methoxy 4-hydroxy mandelic acid, or this product is also known as VMA. VMA stands for vanillyl mandelic acid. Again, AKA lang to, also known as. Okay, AKA, also known as. So, ito yung ultimate degradation product ng norepinephrine, epinephrine with MAO and COMT. Okay? Now, what about dopamine? Okay? What about dopamine? So, next slide, dirita, empty slide ta. Para naalang mo yung idea. Madali lang to. The same enzymes no, are actually responsible for the metabolism of dopamine. So, sulat nyo, sa dopamine metabolism naman, the same enzyme lang po. Okay? We have the MAO, the COMT as well. They could metabolize dopamine. So via MAO and COMT, the dopamine will be degraded into the product called homovanillic acid. Sige lang, naamoy mas elaborate nga a discussion ani sa inyohang org med. Second year man yata ang org medicine. Okay, or third year na siguro ng org medicinal chemistry. Basta dira na ninyo ma-discuss more ang mga reaction. Okay, specifically metabolism, okay, and synthesis. Okay. Again ha, dopamine's degradation product is homovanillic acid. So overall, those are the metabolic fates of natural catecholamine. So kung babalikan niyo yung slides, kanina natapos natin yung synthesis, storage, and release, okay, including the metabolic fate of natural catecholamines, the dopamine, the norepinephrine, and epinephrine. Okay, so please tandaan ang mga metabolic fates nila because as we go along the next chapters, okay, particularly pagdating natin sa CNS class, may mga drugs that will be mentioned kung saan yung mechanism of action nila is to inhibit MAO, okay, mayroon ding drugs that inhibit COMT. Okay, so of course, rationale, inhibited yung MAO, inhibited yung COMT, maiisip nyo agad na yung net result upon inhibition of these enzymes is taas yung levels ng catecholamines kasi mapipigilan yung degradation nila. Diba? MAO and COMT, ito yung kailangan para ma-metabolize yung catecholamines. Since inhibited yung MAO, inhibited yung COMT, taas yung level ng catecholamines. Okay, so taken all together, we are done with cholinergic and adrenergic neurotransmission.